Have you ever wondered what the universe will look like in the future? How the planets, the stars, and the galaxies will look? Well, I'm here to answer that question. Welcome to the fourth episode of The Universe in Magnitudes, where I show you how the universe will look like one magnitude at a time. In the first three episodes, we've covered how the universe will look like in 1, 10, and 100 years. Today, we will explore how the universe will look like in 1000 years. I hope you enjoy. Let's start today's video with something that everyone loves: comets. Many of the comets we know are in highly eccentric orbits. They get very close to the sun and then move extremely far away from the sun again. Comet IKEA, for example, made its closest approach to the sun in 1963. Now it's on its way out of the solar system again, to a distance of 190 astronomical units, and it won't be coming back for nearly 1000 years. There are many comets like this, so they have been put into a group called long period comets, which have orbits that take from 200 to 1000 years. Also, Eris will have completed an orbit around the Sun by now. Eris is the dwarf planet that goes out furthest from the Sun by far. Its aphelion, the furthest point from the Sun in its orbit, is over 100 astronomical units, meaning it goes out 3 times further from the Sun than even Neptune. That's why its orbit takes so long to complete. Looking up into the sky, we find that many of the stars close to the Sun have changed position. There are a couple of stars close to the Sun that move around the galaxy at really high speeds, and on the timescale of 1000 years that movement becomes noticeable. Take Barnard's star for example, the second closest star to the Sun. In 1000 years it will be in a very different part of the sky. Star movement is something that I will be coming back to for the next few videos. Looking into the local group, it is likely that new stars have been formed in some of the local dwarf galaxies. Because dwarf galaxies are so much smaller and much less massive than galaxies like the Milky Way, they produce stars at a much slower rate than the Milky Way does. In fact, a lot of dwarf galaxies don't even produce stars anymore at all. However, those that do, like NGC 185 and Leo A, will have probably produced a few or a handful of stars by now. The same is true for supernovas. There are no supernovas in galaxies without star formation, because stars that have enough mass to go supernova have really short lifespans. The least massive stars that can go supernova live for just 50 million years. Due to that, supernovas are only possible in dwarf galaxies that are still producing stars. But because dwarf galaxies produce so much less stars in comparison to big galaxies, it is likely that supernovas only occur there once every few hundred or thousand years. Within 1000 years, lots of interesting things will happen in the universe. Mainly, this is the first episode where we start to see movement in our galaxy and its stars themselves. This marks a new era in this series, the start of galaxy movement. It will be mentioned a lot more in the coming episodes, as its effects start to increase rapidly. Thanks for watching this video, and I will see you in 10,000 years.